Hey everyone, I'm Sabah, and welcome back to the Security Architect's Playbook. This is my fifth episode, and yes, I'm still here trying to make complex architecture slightly less painful to understand. If you're trying to grow into a proper security architect, you're at the right place. All right, let's go into this. So, this session is all about assessing a Kubernetes security architecture. And this session is not about tools or any hardening checklist. So it's about how a security architect look at a Kubernetes architecture or environment and judges whether it's safe enough to run real world workloads. We'll focus on the trust, the blast radius, and the failure path. And we're not going to focus on how to build a perfect architecture. All right. So we'll start by understanding the architecture at a high level, as usual. Then we'll go layer by layer, starting from identity and the API server, moving into RBAC, admission controls, the workload itself, even the networking, supply chain, and we'll also talk about the visibility. All this, right? And at the end, I'll give you a practical assessment checklist, and we'll also talk about some common failures I keep seeing in multiple organizations, right? We'll just talk about those common failures as well. Okay. As usual, this is a sample Kubernetes security architecture for your reference. So this diagram will be your mental map. Everything in Kubernetes usually revolves around the API server, what you see here, users, automation, and pipeline all talks to each other, right? So remember this diagram, or even like pause, take a screenshot of this and refer when we talk around the security maturity of the architecture itself. Now, when it comes to the control plane, what we just saw in the diagram, right? So the control plane actually decides what should happen in a very short way, right? And the worker nodes actually execute the workloads. Then the ingress that exposes services to the outside world, CI/CD pipelines, those continuously push the codes in. We already spoke about CI/CD pipeline related architecture in one of the other episode. Refer that as well if you want deep understanding. So, as a security architect, I'm already thinking where the trust is concentrated and what happens if one of these layers gets compromised. I believe you're also doing the same thing, right? Now, let's move on to the entry points and the identity piece of it. So, Kubernetes doesn't really care if request comes from a human or from a machine. It only sees identities, right? So you typically have admins, your developers, CI/CD systems, and even service accounts inside the cluster altogether. Most of the modern setups use your OIDC or SSO, which is good. But the real question here is how tightly these identities are scoped. So whether these are really required, whether these are really intended to do that particular work, right? So that need to be verified as well. So during assessment, I usually ask first thing, who can reach the API server? That's very important, right? And how are the tokens issued? What happens if one of those tokens gets stolen? So these need to be our focus at this particular layer. Then moving on to your Kubernetes API server, as we already mentioned, this becomes the most critical component in the entire cluster, right? So every create, update, delete, and even the read goes through the API server itself. Imagine if a attacker gets strong access here in this layer, the cluster is completely owned by them, right? So we look at access control as a prime measure here, the exposure, and especially your audit logging. So if audit logs are disabled or even audit logs are incomplete, right? So you lose the ability to understand what actually happened during an incident. So make sure all these are intact. And moving on, your authentication and the RBAC piece. So this is where many Kubernetes environment quietly fall, right? So RBACs usually look neat in theory, but in practice, cluster admin will be everywhere, right? So make sure you verify this. So as a security architect, okay, in this layer, what I review is who has cluster-wide access. First thing, why do they need it? What are the real business cases they need cluster-wide access everywhere? Are namespaces actually used as trust boundary, or namespaces are just used like a label here? It's supposed to be used as a trust boundary, right? And in this layer again, least privilege, we all talk about least privilege everywhere, right? It's not just a slogan here. It directly controls your blast radius. So make sure everything follows least privilege here. Then comes your admission controls, which are one of the most powerful security feature in Kubernetes and also one of the most ignored, unfortunately. So this layer checks workloads before ever they run, right? So it can block privileged containers, risky configurations, and even your policy violations. So if admission controls are missing, you're trusting developers to always do the right things. Do you think that always happens? So that usually doesn't end well. So make sure your admission control layer is mature enough and have your admission controls properly configured. Then your control plane components. So components like your etcd security, which is a key value storage component usually, and the scheduler, the controller, all this, right? So this manages the entire cluster state itself. So etcd is especially sensitive because, as I mentioned, it stores secrets and configuration. So as an architect, I check the encryption here to start with. Then I'll check the access path, how exactly the access is being done, the backups, and also the isolation. So this all becomes prime in this particular layer. So security here is not just about stopping attacks, right? It's also about being able to recover when something breaks. So the backup becomes important as well. And then, okay, so this is where workloads actually run. So if a container escapes or a node is compromised completely, the question becomes how much damage is possible, right? So I, as a security architect, look at host hardening as a first thing here. Also, the privileged workloads, if you have any, you need to know the reason why those are privileged workloads, and mainly the runtime visibility, right? So, runtime security is not about alerts alone, right? So, it's about limiting how far an attacker can go once they are inside. So, I don't want to read through all I have mentioned in my slides, but I'll encourage you to pause for a minute at every slide and read them to get more understanding on each layer's deep focus, what we're trying to do, right? Moving on, network and the ingress. So here, by default, Kubernetes network is flat. Everything can talk to everything. That sounds convenient, right? But it's also dangerous. So ingress, this controls north to south traffic, but east to west traffic between the different ports, right? It's often wide open. So as a security architect, usually we expect the network policies with a default deny mindset. If those policies don't exist, lateral movement becomes easy, right? So that's going to happen. So make sure default deny mindset, the configuration all holds this particular mindset and it's all configured using this mindset. Now, moving on to secrets and configuration. So if secrets are stored in a YAML file, for instance, right, they will leak. So it's just a matter of time. So here we usually assess how secrets are stored, how are they rotated and accessed. So external secret managers, some short-lived tokens and proper auditing. All this matter a lot, right? So make sure all this exist. Secrets are usually uh, trust in a portable form. That's how I'll say, right? So they need strong handling. So handling them, when I say handling, again talking about storage, rotation, and how are they being accessed. Make sure you're focusing on all these things when you do your assessment in this particular layer. Now, moving on to the CI/CD and the supply chain piece of it. So this is one of the most underestimated risk, right? So CI/CD systems often have broad access and high privileges as well. So I look at how images are built, how are they scanned, how are they signed, and how are they promoted as well, right? So if a pipeline is compromised, Kubernetes will happily deploy malicious codes for you. So security architect treat the supply chain as part of the architecture, not as someone else's problem, right? So we need to make sure how exactly your supply chain is secured. So then, okay, you can't secure what you can't see. I keep saying this in different episodes. So, and in Kubernetes, visibility is often fragmented. So, we want API audit logs, runtime logs, and even your network visibility all tied together. Not just logs, but the context need to be there, right? So, if you can't explain why access was allowed or sometimes why access was denied, you don't really control the system. So make sure all these are recorded, right? So that's important in the observability piece of it. Now, when it comes to the assessment approach here, this is a mindset difference altogether. A solution architect usually asks, does this work? Because that's their duty, right? A security architect asks, how does this fail? That's the difference, right? So I identify usually the assessment path, then the validation of trust boundaries, again the review of how control placement is being done, and always think in the term of blast radius, right? So the goal here is not perfection. The goal is controlled failure. So this becomes my assessment approach usually. Again, pause and read through this. You'll get a little deeper understanding. And okay, this checklist is not for compliance as usual. So keep this as your thinking tool, right? So if API access is loose or your RBAC is broad, admission controls are missing completely. And as we spoke, if the network are flat, the secrets are not managed properly, or I'll say secrets are unmanaged. CI/CD is over trusted or your logs are weak, then the architecture is fragile, right? You don't need everything perfect. You need the critical pieces to be solid, right? So make sure you use this checklist while doing your assessment. And as usual, these failures, the common architectural failures, what I keep mentioning, right? So these failures repeat everywhere. So too many cluster admins, no control, no admission controls, no network segmentation, secrets in manifests, no runtime visibility, CI/CD pipelines trusted blindly, right? So these are not edge cases, right? So these are normal failure modes by itself. To wrap up, Kubernetes security is not about tools, as I already mentioned. It's about the architecture itself. So, strong identity, protected control plane, proper segmentation, hardened supply chain, and real visibility. All this makes your Kubernetes manageable. So, as a security architect, your job is not to say this is secure. Your job is to say this fails in a controlled way. So, that's real security architecture all about. So, thanks everyone for listening and see you in the next episode.